Okay, in this training, we'll go over running a simulation in parallel, but using the MathWorks Parallel Computing Toolbox and the MathWorks Parallel Server. So the first thing you want to do is go to MATLAB. Just make sure that you actually have the cluster set up and configured. So you would install the MATLAB Parallel Server, and you would configure the worker machines that are part of your cluster and just following the directions in the documentation that MathWorks provides. We're using the MATLAB job scheduler, so that's the version that this demonstration is using. The other thing to confirm is if you go to MATLAB, you want to make sure that the cluster you have is configured correctly, and you can do that by going to the ribbon and selecting Create and Manage Clusters. And you can validate and run a validate on your cluster. And you want to make sure that you have all green check marks. That means that the communication between your machine that has the Parallel Computing Toolbox installed is communicating correctly with the cluster. Because if that part isn't working, then your simulations won't run. Now you can see that the validation completed and that the local machine was able to communicate with the cluster. It was able to create jobs. It was able to create jobs of different types. And then it was able to create a parallel pool. The other thing to note is make sure that you're doing the validation on the correct cluster profile. So here our cluster profile is MJS profile 1. There's also the local profile, but in this case, the workers on the cluster on the remote machines are actually connected to this MJS profile 1. So we want to make sure that that's the profile that we're using when we're in the Amber user interface. You can also check that by doing par cluster in MATLAB and passing in the name of the profile as a string. You could also get information about the cluster that way. We can see that we have 48 workers. So what we'll do next then, the other thing to note is you want to make sure that you have on each one of the worker machines a version of Amber that's been installed. So you want to make sure that the parallel server is installed correctly according to MathWorks specifications. You're running the MATLAB job scheduler. You have configured and tested your profile to make sure that communication between your machine using the Parallel Computing Toolbox is working correctly. And you want to make sure that you have a copy of Amber on each one of the remote machines. The other thing too is we'll just do ver here, and you can see that we have the Parallel Computing Toolbox on this machine. So we'll go to Amber, and in Amber we'll select the Run Many Vehicles workflow. And then we're going to select a few vehicles here. We'll select 5 vehicles. And then we're going to select running on a cycle. We'll use the 505 cycle, drag and drop that. And then to enable using the Parallel Computing Toolbox, you click here, Run Using Distributed Toolbox. Now I'll turn it on. We want to make sure that we select the correct profile. So we have our Example cluster profile here. You can see that it's MJS profile 1. If you want to look at the XML file that's backing it, you can go here and see the XML file. In some cases, if you want to create another example file to run with a different cluster with a different name, you would basically go here and then save the file out. And then change the name here to match your cluster profile. or your MATLAB job scheduler. And just save that. Let me close this file. We'll continue the example with the example cluster that we have set up with the MJS profile 1. I could also edit this file by going to edit, and you'll see all the options that are there. There are a few options that we want to kind of take a look at. Many of these options are the same options that you can find in the MATLAB documentation. So a lot of these are options on a job, such as attaching files, adding additional paths, having a callbacks for queuing and running and when a job is finished. The task capture diary option is turned on here. Also, there are task callbacks that you can set up. So basically, any of the parameters that you have in MathWorks in there that you can set on a job or a task, you can add to one of these profiles so you can access them in the user interface. Just want to point out a couple of things here. We won't run the cluster preparation, but there are a few options here we want to take a look at. One is where we save the results. So this is set up to save the results on a shared drive. So all the worker machines have access to this common area. So when they're running, they will save the results to the common area here. And then the user interface will load those results from that common area. There's also the remote path. So what we're telling it here is the remote root path is where Amber is installed on each one of those machines. So all of our worker machines, if I went to and logged into each one of the machines that are running the workers, you would find Amber under this folder, E:\Amber worker. So you want to make sure that your Amber is installed on each one of the remote machines on the cluster underneath this folder. It could be a different folder, so you could have it under C/Amber 2023. That would work. Just make sure that you have it installed. Sometimes you might have multiple people using the cluster, and each one of them would have their own copy of Amber that they're running, or different versions of Amber. So it's useful to be able to set this root folder. So you can go through and save these options and reuse the profile later. This is where the file is being saved. So I'm saving under projects, default example, adist is the file name I'm using. We'll click OK. Just say yes. And then what we'll do is we'll just run the simulation. So it'll run each one of these simulations on the cluster and then load the results. As it's running, you can see it running here. You can go to a different session of MATLAB and then use the parcluster command to access your jobs as it's running. You can see that we have a job running here. And it's this last job, which you can see is running on the machine. You can see that it has 5 tasks, and those 5 tasks correspond to each one of those vehicles that is running. Okay, now you can see that the results have loaded. So each simulation, all 5 of them have loaded. So the results were stored in this remote drive. So it's a drive that is shared among all the worker machines. So they all have access and permissions to write to this folder. And Amber has permission to read from that folder. So it loaded all the results from that folder, and you can see the simulation runs for each one of these conventional vehicles. And it's just as if it ran locally. So we can open the result. And view the report. And that completes this training.